Recording is rolling. It is Thursday, August 21st. So you guys have your Algebra 1 review packet. It has 7 sections in it. I just need to cover section 7 with you guys today. I've done at least a couple from all the other sections. Remember, I'm going to pick this up tomorrow. Guys, got to pick this up tomorrow. I'll let you turn, if you finish it today, if you turn today, that's okay. As long as you do at least 4 puzzles per section, and of course there's 7 sections, so minimum 28. I'll give you full credit for that. You can always do extra, that'll only help you. Guys, can you guys bring your laptops tomorrow? So I'm going to open up the general knowledge test tomorrow, and then I think that'll be a good time for that. Speaking of tomorrow, we're going to be on it. Oh, yeah, go.
You said forward a memo for each section, but if you do more of that extra credit or no?
Oh, wasn't planning on it.
Oh,
But yeah. All right. Tomorrow we're on a pep rally schedule, so the costs are a little bit on the short side. I don't know how long this general knowledge test is. I don't think I have a way to see it myself. I was digging around a little bit, but I'll look at your guys' screens and kind of gauge an idea like how long it would be, or I don't know. But guys, keep in mind, fast test is this Tuesday. I think most of you guys are gonna be taking that, so it's gonna be a little bit weird day. But the list of locations is on Google Classroom. Here we're gonna be. Okay, so any questions about agenda? What we're doing? That. All right, so let's look at section 7, okay, which is these word puzzles. Word puzzles. Now these are fun. Uh, so, uh, so there's some kind of practical applications type question. And remember that all of these you can make some mathematical model. That's kind of the point, right? You can make a mathematical model. Now everything we've done up to this point is like really abstract. It's like, okay, well, I guess if you graph this, let's go look at a parabola, and okay, I got x's and y's and right. But now we're at this application section. So, um, salesman sales increased by 20% to $60,000. What were his sales the previous year? Can you guys set up an equation that could represent that scenario? And I'll give you guys a hint. When it says what were his sales, that's what you're solving for, right? Can you call that a variable? For example, x. Can you call that x? Right? So there's going to be an x somewhere in an equation. That's what you're solving for. And that x is going to represent the sales the previous year. Right? So first set up the equation that represents that question. Okay. And we'll be able to do some algebra to solve for x. All right. What equation did you guys come up with? Yeah.
60 divided by 5 times 4.
Uh, yeah. It's not. Let me this in here. It's here. Point. Okay. Um. Okay. So here's what I say. Whatever sales were the previous year, I'll call it X. Okay. Now, if it says increased by 20%, oh yeah.
I just did 60,000 divided by 1.2.
True. That'll get you the answer. Yeah, right. Now, what I'm going to do is do a step before that, say like what would kind of lead to exactly what you said, right? So here's how I'm thinking of it. Because you said a factor of 1.2, right? Okay. Because see, if I took what he made last year, which was solved for, okay, and I multiply that by 1.20, wouldn't that be increasing by 20%? Because if it didn't increase at all, if he said he had no increase at all, then that'd be multiplying by what? Yeah, 1, right? Which would be just like the status quo, the same thing. Because what if you only multiply by 0.2? Wouldn't you be saying that he's getting a huge salary cut? He's only making 1/5 of what he made the previous year because 0.20 would be 1/5. Okay. So I want to multiply by more than 1. Okay. Another way to say this is 1 plus 0.2. Right. 0.2 would be 20%, right? It's the same thing. Okay. And that's going to equal what? Yeah, 60,000. Okay. In fact, since I also teach physics, I'm kind of a stickler for units, and the unit here is dollars. Okay, so $60,000. Okay. Yeah, and then there's only one algebra step, and that's to do what to both sides. Yeah, divide by 1.2. Great. Okay, and that will get it for you. So let's say what's 60,000 over 1.2? Okay, so look, X, what he made last year is 50,000, and that's dollars, $50,000. Okay. Okay, so, all right, that one won't do bad, right? Okay. Basically do increase sales. Okay, 47. This one. Yeah, Alan, Bob, and Chad have ages that are related. Chad is 3 times older than Alan. Bob is 2 years older than Alan. In 6 years, Alan and Bob's combined ages will equal Chad's age. How old was Chad? Okay. I was trying to help you out, and I said, well, I think I gave you like a wrong hint, and I said actually change that because it would change the answer. Like the hint I gave you, I told you to ignore what I said. Okay. So let's stick with the wording exactly as it's printed. Um, okay, so we get system of equations. Now, guys, the fact that there's 3 people here, there's an Alan, a Bob, and a Chad, might be a hint as to how many equations you need to be able to solve the scenario. Because if you have 3 people, guess how many equations you need? Three. Yeah, you need 3 equations. Okay. Now, what's one equation? Let's start with this sentence right here. Chad is 3 times older than Alan. How can I write that as an expression? Yeah.
So if Alan is X, he can everyone else's age, and but him and Chad is 3X.
Yeah. Chad would be 3 times whatever Alan is. Okay. Now I'm going to use A, B, and C to represent their current ages. So A for Alan, B for Bob, C for Chad. Okay. Yes, and then I'll do exactly what you said. So I'll say Chad is 3 times older than Alan. So wouldn't that be 3 times A or 3A? Right? No, we don't know, of course, what their ages are yet, but if Alan was 10, then Chad would be 30. If Alan was 8, Chad would be 24. Okay. Okay. Huh? Oh, you got the whole thing? Yeah. Ooh, all right.
I already did. I thought we had to do this for homework, so I get it already.
Ooh, all right. Nice. Yeah, looking at yeah, step ahead. Okay, awesome. Guys, what's the next this next sentence right here? Bob is 2 years older than Alan. How can you make that an expression?
A plus 2.
A plus 2, you guys think? Right? A plus 2? Because it says 2 years older than. So it's like an addition, isn't it? Oh, yeah, that would look a little different. Something like Bob is, you guys know is usually translates as an equal sign. Right? 2 years older than Alan. Yeah, so wouldn't that be Alan plus 2? Or you could say 2 plus Alan. Either way, right? Okay, so that's 2 equations. Okay. Now, guys, can you solve exact solutions with for 3 variables with only 2 equations? No. All right. So, but you guys already told me that. You said you need a third equation, right? Yes.
Equal, then parentheses, A plus B on the outside of the.
Okay. Yeah. So we're getting down to this third sentence right now. Guys, this third one I think is a little tricky to model, and depending on again how you interpret the question, you'll get different results. So I'm going to try to stick to what I think they're trying to get at here. They say in 6 years. So isn't it true we're going to age every person up by 6 years? They're all going to gain 6 years. Okay. It says Alan and Bob's combined ages, again, 6 years from now, will equal Chad's age. Okay. So we say Alan 6 years from now plus Bob 6 years from now, because isn't that what combined means? Is we're going to add them together. Okay. How did you write that? Here, I'll give you guys a head start. Okay, so write that third equation. So 6 years from now. Okay. You guys know A stands for Alan's current age, like today. B stands for Bob's current age today. But we're talking about 6 years in the future for each of them. Then you're going to combine those. That's to say you're going to add them. Yeah, and at that point, 6 years in the future, it will equal Chad's age, of course, also 6 years in the future. Okay. Okay. Yeah, what you got?
A plus 6 for Alan.
A
Plus 8 for Bob.
Yeah.
And then 2A plus 14 for Chad.
I'm just going to do this. I'm going to say Alan plus 6. Won't that be Alan's age 6 years from now? Alan plus 6. Okay. Plus, and then what would it be Bob 6 years from now? So Bob plus 6, right? Right. So whatever his current age is, just B, and then plus 6 is I'm aging up 6 years. Okay. And then what will Chad be 6 years from now?
3A plus 6.
Well, I'll just say C plus 6, right? Whatever that is. Okay. Now, and I'll let the algebra go ahead and I mean you might be right about that, but I'll let the algebra lead to the answer from here. Okay. So this is exactly what I would write. Here's my I'll put a little curly bracket. I'll say a system. That's my system of equations. Yeah. Great. Okay. Does that make is there any question about how I set up that system? Okay. By that matches that. Okay. All right. So maybe I can split it this way. It makes sense. Okay. Now, there's different ways you can solve systems of equations. I'll write some methods over on the side. Because what's one method you can use to solve a system? I'm thinking method starts with an S, method starts with an E, method starts with a G. and a method starts with an M. I can think of 4 different methods. What's one method? Yeah.
Substitution, elimination, graphing.
Aha. Substitution, elimination. Yeah, a graph. Yeah, graphing. True. Right. That one's a little iffy, but I guess you couldn't principle, right? Yeah. And yeah, does anybody know what the M stands for? Okay, that's okay. Right. It's called a matrix. Okay. Actually, I was looking in your textbook, and it's one of the last chapters in your textbook for next semester. So, yeah, probably next semester. Right. So, you guys tell me, what do you feel like using? Substitution? Sure. Let's use substitution. Let's go with that one. Of course, they should all ideally lead to the same answer anyway. Okay. All right. So, what do we know here? Ooh, how about this? How about this? Okay. Now, there's lots of ways you could substitute. There's probably, I don't know, maybe 10 or 20 different ways you could do this. Could I take Chad as 3 times Alan? Could I substitute that right there? And I'm substituting out the C. Like if I sub that right in there, it's going to be no more C's. It's going to be Alan times 3 plus 6. Okay. I'll have it all in terms of Alan. Okay. And then could I take this B, Bob, and substitute right there for that B? Of course, in terms of Alan also. Right? That would give me one expression that's all in terms of Alan only. Do you guys see that? Here. See if you guys visualize it before I write it down. Okay. But I have this Alan plus 6 here. Alan plus 6 plus. Okay. Now instead of Bob plus 6, what am I going to write right here? Aha! Isn't Bob actually Alan plus 2? So brackets to make it really stand out. And then, of course, I still have the plus 6. Okay? You guys see, who has a question where this part comes from? You guys see, I just, in place of Bob, I just put Alan plus 2. Okay. And then, that's all equal to, now instead of Chad, what am I going to write? 3 Alan. That's right. You guys see, it's going to substitute right there. Okay, now I still have the plus 6 on this side also. Okay. All right. Okay. So, yeah, I think whatever you're supposed to get out of this word puzzle, that's the main concept. Like ideally, you could set that up. You could get to that point. Okay? Because everything after this should just be we're back to regular algebra, just like we've been doing all week. Okay. If you can get to that point. Okay. 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 So, here, you know what? I will solve this off screen. You guys finish solving that, and let's get a value for Alan. I'm going to solve this off screen, and then see if we got the same thing here. Oh yeah. Yeah. Go ahead. Take that. Fantastic. Okay. Off screen, I have how many years old Alan is today. Who can tell me? Who knows how old is Alan? What you got?
8.
And you got
30.
and you got
8.
8. Okay.
Oh,
Oh, yeah. So okay, Alan. Yeah. All right. Okay. Okay. I'm hearing a few guys tell me 8. Right. So I just took this right here. I just cleaned it up. Isn't this A plus this A? I can combine that and make 2A. I can do that. And then I have a 6 and a 2 and a 6, and I think that makes 14. So that looks like this line right here. Isn't that true? And 3A plus 6 on the other side. Okay. Then get the A's together. So I'm going to subtract off 2A from both sides. And that brings me to just plain A here, which I'm solving for, of course. Okay. And then subtract 6 from both sides. Yeah, and that leaves you with 8. So I know Alan is 8 years old today. Okay. Yeah, and that's what you guys told me too. Okay, you guys said Alan's 8. Okay. Now, if Alan is 8, so I'll put A equals 8. And of course, that's years, I guess, right? Attach a unit to it. 8 years old. All right. Now, can you go back up to your beginning system of equations and very quickly get Bob and Chad out of that? Okay. So Bob is how old? 10, because you just do 8 plus 2, and Bob must be 10. So Bob must be 10 years old. Okay. And Chad is what? Yeah, 24, because 3 times 8 would be 24, wouldn't it? Okay. So Chad is 24 years old. Okay. So that should be the answer right there. How many of you guys got 8, 10, and 24? How many of you guys got that? Yeah, yeah. Oh, look at you guys go. Oh, yeah. Oh, yeah. All right. Ready for our next one? Next one. Number 48. Got a cab ride cost $3.25 for the first half mile, and then 70 cents or $0.7 if you like for each mile after that. Right. So it looks like they're charging a lot up front, and then every mile after that, it's not as much. Right? How far can someone travel for $12? Huh. Huh. Right. I think this will be a little trickier setup, but yeah, we can set this up. We can turn this into an algebra equation. Top for $12. Hold on. Okay. Um, let's do here. I'm gonna introduce some variables. Could this be like y versus x? But instead of y and x, maybe we could put c for cost, and well, maybe I'll keep x for distance. Okay. So I'll see c is equal to the cost, and I'll say x is equal to the distance. The cost will be in dollars, and the distance will be in let's say miles. Yeah, I'll stick to miles. Okay. Okay. Here, give you guys a shot here. See if you can take this word problem and set up an algebraic expression that represents that scenario. I'll give you guys a little hint how I'm thinking of it too. Right, I'm gonna sort of assume that just stepping in the cab, you lose 3.25 right away and sort of get the first half mile for free after that. Right. So the way I'm going to model the equation is, let's say, like, even if you only went like a tenth of a mile, you still pay the 3.25. Okay. It's going to look like an intercept on the graph, maybe. That's what I'm trying to get at. All right. You guys got an equation? Let's see. Show of hands. How many guys have an equation written for this? Okay, I'm seeing 1, 2, 3, 4, 5 hands. Okay. So who feels pretty confident wants to volunteer to answer? Yeah. What's your?
I got 13 on.
Well, okay, not to solve the whole thing. Actually, I don't know what the answer is quite yet. Well, I'll work it out with you guys. That might be the answer. I see. But
I'm kidding. 12 minus 3.25. Then I'm divide that by 0.7.
Okay. I think the does anybody else have anything different? What you got? Okay. Again, not jumping straight to the answer yet. I don't know what the answer is yet. What you got?
Plus 0.70x.
Ooh, okay. I wrote something really close to that, but slightly different. What you write?
0.7 times x minus 25 plus 25.
Okay, that's what I did. Yeah, that's what I did. Okay. So I said the cost would be equal to right. Yeah, let's say 325. So 3.25. And then plus. And then isn't it 0.70, so it's like 70 cents or $0.7, right, per mile, which would be like X, right? But you sort of already paid for the first half mile. So this 70 cents, you're not paying for that first half mile. So you do have to subtract it out to be like X minus a half. And then, well, this would be miles if you had a unit, right? Right. Per mile, per mile. Right. Here, I'm gonna make this too fancy. Let me get rid of all those units. Let's just say C equals. Here, I'm going to do this also. I'm going to swap these two terms so it looks like y equals mx plus b. Guys, isn't this basically y equals mx plus b? Okay, so I'm going to move this over here. Say 0.70. I'll drop the dollars just to make it stand up clear. X minus a half, and then plus 3.25. Now, let me show you guys why that works for the first half mile. Okay, guys, suppose you jumped in the cab and you go the first half mile. Okay, wouldn't x be equal to a half to stand for a half mile? Because what is a half minus a half? That would be zero, right? That would be zero, which is to say that you aren't paying this additional fee at all, and you only pay the initial fee to pop in the cab for the first half mile. Is that right? So I'm treating the first half mile fee is basically like an intercept on the graph. Okay, like pay that no matter what. Is that okay? Okay. Another way to think of this, guys, do you guys learn about graph shifting, the shifting graphs, like right and left and up and down?
Mhm.
Right. Okay. Guys, when you see this right here, this minus like x minus a half, like collectively, that's to say it would be shifting a graph which way?
Right.
To the to the right, right? Okay. So let's say this. So if I make a graph out of the well, maybe this on separate paper. Right. What would this look like as a graph, right? So here's C for cost. Here's X for the distance traveled. Okay. If you haven't, well, let's say that. Okay. Let's say, here, gotta put some numbers on here. Okay, this would be in miles. This is in dollars. Okay. So you go 1, 2, 3, 4 miles. Okay. And I know there's something special about the first half mile. Okay. And at that point, it has to be 3.25. Okay. Isn't that true? It has to be like $3.25 at the first half mile. Okay. Okay. Then everything after that, it should increase by 0.70. So wouldn't that be like a slope? Like the slope right here. Could the slope be 0.70? And the units would be dollars per mile. Okay. Okay. Now let's see if that's true. Because I can pick let's say this point right here. Let's see what does that look like on the graph, and does my equation correspond to that? Okay. Does it all match? So this is a half mile right here, isn't it? Like a half mile? Okay. And it's 70 cents per mile. So how many dollars would it be to get this extra half mile? Or how much money?
That's 70 cents.
Yeah, half of 70 cents. Would that be like 35 cents? Do you guys see that? Okay. So to get to the 1 mile mark, I have to do this should be 0.35 as in 35 cents on top of the initial 325 fee. Okay. So let's say that's true. So what's 325 plus an additional 35 cents? So that's like 360. So like right here, it's like $3.60 to get to the 1 mile mark. Okay. Okay. Does that agree with my equation? Let's see if it does. This is a good thing to do. If you think you model it right, you can pick a point and kind of test it out, which is exactly what we're doing right here. So if I put 1 mile for X, I want to go 1 mile in this cab. This should come out to $3.60, shouldn't it? Okay. Let's see if it does. That's 0.7 times, and then 1 minus a half. And then plus 3.25. Yeah, 3.6. That's $3.60, isn't it? Right, same thing. Okay. Okay. Yeah, so this is exactly what I'm looking for. Okay. So with all that in mind, let's go to what they actually asked. Is the question is how far can you travel for $12? So maybe you have $12 in your pocket. You just want to like max out your ride. Right? Is what are you going to do with that 12? Where's that go? Aha! C for cost. So you hand the cab driver $12. You say just drive, go, and you're solving for what? Yeah, you're solving for this X right here. So how far can you go on that $12? It's 3.25. Okay. Yeah, this one definitely takes some deep thinking. Let me pause and give you guys time to digest that. Okay, so close the question about where any of this comes from so far up to this point. You guys all following? You guys all good with this? Okay. All right. Okay. Because once you get this part, it's actually not that bad. It's just now we're just back to regular algebra. So what's the next algebra step? Yeah, there you go. So minus 3.25. Of course, both sides. Balance that out. Okay, so that gives me 12 minus 3.25. Looks like 8.75. So $8.75. So 70 cents per mile. And then I still got the X minus half mile here. So I got guess what's I guess there's different ways to do it. Could I divide by this 0.70? Could I do that? Yeah, I could. Great. Alternatively, you could distribute first. So that's up to you. I'm going to take 8.75. I'm going to go ahead and divide out the 0.7. I'm going to get 12.5 is equal to x minus a half. Okay. Now, at this point, this would all be in terms of miles. The dollars, if I kept my units, the dollars would cancel out at this point. Okay. What's the very last step? Yeah, add 1/2. So, should that be 13, it looks like? I think. So I think x is 13 miles. Half. Guys see 13 miles? Okay. Okay. I know some of you guys said you sell that ahead of time. How do you guys? Oh yeah, go ahead.
Why didn't you just do 12 minus 3.35, and then you know that's for half a mile, then you just divide it by 0.7, and that would be 12.5, then you add the other 0.5.
Yeah, that's exactly what we did. Yeah. Exactly. Exactly what you just described. That is exactly what this says. That is it. You got it. Yeah. Yeah. All right. All right. How many guys got 13 miles ahead of time? 13 miles. Oh, look at you guys. Oh my God. Sharp class. Sharp class. Yeah.
Yeah, I got negative 1/2.
Huh?
Negative 1/2. What I did? Like they.
Okay. Because this x is like the total distance that we're going. Right. But I'm going to subtract off half a mile because that's like a separate payment. And then everything after that is like at a rate of 70 cents per mile.
Yes, no, but I'm saying like
This right here.
Yeah.
Huh?
What do you do with that?
So plus 1/2 and then plus 1/2.
Oh.
Right? So 12.5 plus a half gives you the 13.
Yeah.
Yeah. Okay. Hey guys, good?
I didn't.
So we're down here. Got till. Okay, we're doing good. Alright, next one. 49. 49. In a class of 30 students, 60% wear glasses. How many students do not wear glasses? Ooh, how many students do not wear glasses? Next. Guys, go ahead and solve that. I bet a lot of you guys can get that before I give you guys any hints or anything. 60% wear glasses. How many do not wear glasses? Oh, that's for me. Oh, that's not you guys. All right. So, who thinks they know the answer to this question? Here's the answer. What do you guys get?
18.
What are you getting? 12. What are you getting?
Wow.
You're getting
12.
12. Right. Okay. So I'm hearing two numbers. I'm hearing 18 and a 12. Oh, guys, 60%. That would be more than half, right?
Yeah.
What is half of 30 students?
15.
Would be 15, right? So I think more than half are wearing glasses, which means that less than half would not be wearing glasses. Okay. Yeah, so I think if you said 12, that would have to be the correct answer, right? And just for completion here, how would you set up an equation to represent this scenario? So 1 minus 0.60 is what you said is the proportion not wearing glasses. Okay. Because one represent. Guys, what does 1 represent? It represents 100%. That's 100% of everybody. Okay. I'm subtracting off. Guys, what is the 0.60? What does that come from?
60%.
Yeah, that's 60%. So you guys know that, right? To go from a percent to a decimal, it's like 2 decimal places. Okay. So really 60% is actually 60 divided by 100. That's really what it is, right? Like proportion. And then okay, when you see of 30 students, guys, usually the word of translates to what as in a mathematical sense. Multiply, right? Now there might be some exceptions, but as a general rule, usually of means multiply. Guys, multiply what right here? Times what? 30 students. Yeah, 30 students. Okay. And that will give you the number of students not wearing glasses, which is exactly what they're asking. Okay. There might be a couple other ways to set this up too, but that's one way to do it. Sure. Okay, so I'm saying, guys, what's this decimal right here come out to?
0.4.
Yeah, 0.4. So 0.40, 40%, you think? Of 30 is equal to x. Ooh, can you guys do mental math?
12.
It is 12. Can you guys let the decimal float? Like 4 times 3 is 12. and then times 10 here and divided by 10 here. Yeah, so it would be 12. So 12 students. I guess the unit students, isn't it? Okay. Yeah, 12 students are not wearing glasses. Okay. Right. Yes, sir. Right. Oh, last one. Ooh. A rope is cut into 3 pieces. The first piece of rope is twice as long as the second piece of rope. Okay. So I'll call the first piece A, the second piece B, and the third piece C. Okay. The third piece rope, C, is 3 times long, 3 times as long as the second piece, which is B. Okay. What is the length of the longest piece of rope? Guys, what was weird about this question?
Gonna give you a number.
Yeah, you can't actually solve it, and I didn't actually catch that until I printed all these off. It's like, oh wait, oops. Yeah, because you need there to be a hard number somewhere. You either need like to know what is the total rope, or you need to know what is one of the pieces. Right.
Okay.
The best you can do, as it's written, is you can figure out proportionally what they would be relative to each other, or you can make up a number like 100 feet or 100% of rope or whatever. Right. But let's set up some equations and figure out what to do from here. So, how about that first phrase? The first piece of rope is actually I'm going to draw this out a little bit too. Let's have a huge piece of rope, maybe something like L, and it says piece A is twice as long as piece B. Right. So a piece A is twice as long as piece B. Guys, could this right here be piece A, and this could be piece B? You guys see how A is about twice as long as B? Okay. And it says C is 3 times as long as piece B. So, guys, does this C look approximately 3 times that length B right there? Right. Actually, it's probably a pretty good visual, isn't it? Yeah, sure.
I think maybe we do like question 47.
Huh?
We did.
We did 47.
Okay.
Question 47.
Did we did that, right?
We did
Yeah.
47.
Yeah, tell you what, I'll finish this one, and I think we'll have a few minutes. I can come over and help you guys out. Okay. Right. So let's turn this into some equations. When you say A is twice B, what equation does that make? A equals 2B. Could you just say that? Okay. And then they said C is 3 times B, so that'd be C equals 3B. Okay. Actually, that's all they gave you, isn't it? Isn't that all they gave you? Okay. So I'm gonna make one more equation so we can get an exact answer. Okay. I'm gonna do this. I'm gonna say A plus B plus C. I'm making this part up. Okay. Equals. Could I say 100 units long? Is that okay? Could I just say 100 units, like 100 meters or 100 feet or 100%? Okay, because that's the next number to work with, right? Okay. So I just made that part up. Right. But now that'll allow you to solve it. Remember how we're solving for 3 variables, an A, B, and a C. So you need to have at least 3 independent equations to be able to solve it. Right? That's another hint. Okay. So this is my system. Okay. And just like before, you could use substitution or elimination or graphing, or you could use a matrix also to solve it. Okay. Let's try. Actually, substitution is real fast, isn't it? Because couldn't I just substitute this in terms of B here? And this in terms of B here, you get everything in terms of B. Okay, just do that. Okay, that'd probably be the fastest way, right? Okay. So A is 2B, so I'll put 2B right here. Plus, okay, then B is just B right here. Okay. Then in place of C, I'm going to put 3B. Okay, and that all adds up to 100 units of rope altogether. Okay. Yeah, so 6B would represent the full 100 units. So length B itself, would that be 100 divided by 6? Right, which is like, does that come out to like 16.67, I think? And then however many units. Again, this is meters, this could be meters, and this could be meters, right? If you're doing meters, right? Yeah. Now, okay. So, all right, yeah, okay. Let me backtrack a little bit. Okay. So what they told us was length A is twice B and length C is 3 times B. Okay. Actually, that's all they gave you. Okay. This third condition I just made up because otherwise you can't solve it for an exact answer. So if you add all the pieces together, let's call that 100 meters. Okay. Okay. So then I took this A, which is 2B, and I substituted in for this A here. So that's where this 2B came from. This is actually A, it's 2B. Okay. Now B, of course, is B. Okay. And C, I substituted as 3B. Okay. Okay. Now you add that all together, like 2 and 1 and 3, that gives you 6 Bs. So 6 Bs would get you the full length of rope, which I'm calling 100 meters. Okay. Divide by 6, and length B itself, which looks like the shortest piece, has to be that one right there. I got some space right over here. Finish this off. Okay. So if that's B, and A is 2B, so I know A is 2B and B is 16.67 meters. Okay. Then A would be, what is that, 33.3, I think, meters. Okay. So I got A, I got B, so this is B. Okay. And C was 3 times. So so 3 times B, 16.67 meters. I think it's like 50, right? 50 meters. Yeah, right, something like that. Okay, now guys, if you add these 3 pieces up, let's make sure this works. Because here's A, here's B down here, and here's C right here. Guys, add up those 3 individual pieces. What do you get? 100 meters. So then now you're back to the beginning, or the full length of the rope. Right. Now, if you did not include that last condition, the 100 meters, if you just wrote exactly what they gave you on the printed paper, right, then the best you could answer is in terms of proportions. Guys, can you say that regardless of the exact length of rope, that B is always going to be 1/6 of the entire rope, A is always 1/3 of the entire rope, and C is always 1/2 of the entire rope? Yeah, regardless of what the full length is. Okay. All right. So that is the whole packet right there. The whole packet. So remember, remind you guys what we're doing. So we have a few minutes of class left. I'll walk around, help you guys troubleshoot any questions you guys have. Tomorrow, bring your laptops for the general knowledge. And when you finish, at least these 28 questions, then you can turn this into this great tray.